Alright, welcome students. This is the video for, whoops, didn't start my pen, for domain and range. And we're going to be talking about discrete. Okay, and we learned in last class period that discrete is just dots on the graph. Discrete dots. Okay? I want to introduce, let's go on to the next slide. Domain is all the x values, and range is all the y values. So an easy way to help keep those straight is we created something to help you remember. Dr. X, Y. Domain is X, range is Y. So Dr. X, Y helps you keep track of which one is which. An ordered pair is the X and Y location of a point. And we do an ordered pair like this, X, comma, Y. A mapping diagram is a diagram that uses bubbles and arrows to show points. So that may sound weird that I said bubbles, but by bubbles we mean bubbles like this. And you would put your numbers in here: 1, 2, 3, 4, 5, 6, 7, 10. And so if 1 went with 7, you would draw an arrow 1 to 7, 2 to 5, 3 to 10, and 4 to 6. And I'm just making up those numbers just to show you what a mapping looks like. Discrete data is points only, just points. Continuous data or graph are connected lines or curves. Okay? So it's a graph. It could look like this. It could look like this. Okay? Just as long as you can see the actual line or curve, then you have a continuous graph. Alright, so we're going to get into the actual problems that we do for domain and range. What I like to do is a color coding system. So for everything domain today, I'm going to do red. And for everything range, I'm going to do blue. So we learned today that Dr. Whoops, let me erase that. That Dr. XY, so the D and the X would be red, the R and the Y would be yellow. So domain, so if I do my domains, these are going to be all my X's that are listed here. So if I list my domain, and we like to list them in order from smallest to biggest. -1 is the smallest, comma. 2.3 is the next biggest. 4 is actually next. And 5 is next. Then we go to my range. Those are my Y values. So my smallest Y value is -2. Next smallest is 7. And those two are tied at 9, so I only list them once. We only list repeaters one time in there. So this is how you do the domain and range of discrete. So pretty easy. It's just a matter of being able to label them X and Y, and then remembering that range is Y and domain is X. Alright, let's take a look at the next style of problem. Okay, again, domain, domain, range, range, Dr. X, Y. Okay? Alright, so I want to do them in order again. So my lowest X value is here. So -6, comma, -1, comma, 1, 3, and 4. Switch over. -8 is my lowest Y. Then -4, then 7, 11, and 13. And I'm done. On to the next. Here's your mapping that we talked about. Again, X, Y, X, Y, Dr. XY. So these are my domain. Smallest is -2, then 3, then 4. My range, smallest, -2, Next smallest, 0. Okay, so again, pretty easy. We don't have to worry about the arrows. We'll get more into those when we talk about the different parts of the function and lines and stuff like that, but for now it's just this easy. Alright, the ones on the graph are a little bit more difficult. So domain are all the places where it crosses here. Range is all the places where it crosses this line. So we got to take each point and we got to draw to that line. So I always start from left to right because left is going to be my smallest over here. Right, so this is going to be small and this is going to be my biggest one. So my first dot is right here. So I draw up to the red line. That's -1, -2. And the next one is here. That's -1. I don't have another one till way over here, so that's 1, 2, 3, 4, 5, 6. Okay. So then we go to the blue. For blue to do smallest to biggest, we got to start from the bottom and go to the top. So this will be our small numbers down here. This will be our big numbers up here. So we start going up. That's the lowest one, -1, -2, -3. Then the next is here. That's at +1. And the furthest one is up here at the top. That's 1, 2, 3, 4, 5. The other option is to go through and list all the points. So if I were to list the coordinates of this point, that's at -1, -2, comma, 1, 2, 3, -3. Then I'll do this point. That's -1, 1, 2, 3, 4, 5, -1, 5. And then this point here is 1, 2, 3, 4, 5, 6, up 1. So this one is 6, 1. Then our domain is this side, which is -2, -1, 6. And our range is this side, which is -3, 1, 5. And so you can do either one. If you're good at plotting the points, you can write it that way. If not, you can try to draw the lines. You just got to figure out what's going to work best for you. Alright, so here's what it looks like in terms of a word problem. It says, let's say we have a whole box of brand new tennis balls. Tennis balls come in 3 to a can. Since the number of total tennis balls depends on the number of cans you have, the cans are independent. So this is our x. The number of cans are independent. So this is going to be the number of cans. Our y's are going to be our dependent. This is the number of actual tennis balls. Alright? So when we go to the store, could we buy 0 cans? Sure. Could we buy 1 can? Could we buy 2 cans? Could we buy 3 cans? Could we buy 4 cans? And so you have to think about what types of numbers could you not buy. Okay? And so for this, we can't buy decimal or fractional cans. Okay? They would not let you buy 2.5 cans. That doesn't make sense. Okay? So now let's switch over to the actual number of tennis balls. Because there's 3 to a can, if we buy 0 cans, then we will have 0 tennis balls. But if we buy 1 can, we will have 3 tennis balls because they come 3 to a can. If we buy 2, 2 times 3 is 6. If we buy 3, 3 times 3 is 9. 4 times 3 is 12. This would keep on going. We could buy as many cans as we want. And this would keep on going up by 3s, as many as we want. Okay? This data is said to be discrete because the tennis balls are countable. We can't have half a tennis ball or half a can, so this is said to be discrete. Okay? It's also discrete because you can't buy 2 tennis balls, or you can't buy 7 tennis balls. You can't buy the numbers that are in between here either. Because they come 3 to a can, you can't get any number besides these down here, and so that's another reason that makes it discrete. Each gives us a bunch of different situations. I'm going to do the odds with you here, and then I want you guys to do the evens and bring the whole thing complete to the class. So we got to decide continuous or discrete. So we can just do C or D. The number of children in a household. So you got to think, can we have half a child? Nope. So it has to be discrete. The time you sleep at night. Can I sleep half an hour? Can I sleep 2.5 hours? If you can, then it's continuous. Okay? Harry is creating a graph of all the skyscrapers in downtown Dallas and the number of floors in each building. skyscrapers and floors. Can you have decimal skyscrapers and decimal floors? Okay. You're not going to have half a skyscraper, and you're not going to have 14 and a half floors. So this is discrete. Down here in number 7, you have a $20 gift card to buy food at Sonic. So is it going to be continuous or discrete? Could your gift card go to $19.98? Could it go to $18.52? Remember, you're buying milkshakes, food, slushes. So you're buying prices that cost all different things. And so the answer is yes, this is continuous. Your gift card could have any amount from 20 all the way down to when you spend it all $0, depending on the types of things that you buy. Okay. Make sure you finish this up and bring it in on Monday. Have a good weekend.